Okay, so this is the beginning of algebra right here. This is where algebra is born because we have a problem where we want to know what number do I add 14 to it, and I'll get negative 12 when I add 14 to that number. That's essentially what this is getting at. Sometimes people lose sight of that. We're just trying to find some number that if I add 14 to it, I'll have negative 12. So let's go try to show first off how you do this. All right, for this problem, it's key to note that the opposite of addition of a number is subtraction of a number. Those two things are inverse operations. All right, and in a later problem, it's not for this problem now, but I will also learn and talk about the fact that multiplication is the opposite or inverse of division. All right, let's talk about a real simple example here. Let's talk about changing the tire. Let's say you got a flat tire. All right, what do you need to do to fix your flat tire? So the first thing you need to do is you need to jack the car up, right? You need to raise the car. Right, the car needs to go up, and then you loosen the lug nuts, right? And when you loosen lug nuts, what do? You turn them counterclockwise, right? And then you remove the tire. All right, this is going to seem really simple, and you're wondering like, why are we even talking about this? Everybody knows how to change a tire. All right, when we want to, now we've got the tire off, what do we need to do to get the tire back like it was? What's the first thing we do? We don't let the car down, and we don't tighten the lug nuts and then add the tire back on. No, we don't do it in that order. You have to do the very last thing that you did to undo, that you were undoing, you have to redo that immediately. All right, so the first thing we do is the last thing we just did and the opposite of it, right? So the opposite of remove the tire is put the tire back on. So put a spare, whatever, replacement tire back on. So these two things here are opposite steps. They're inverse. It's probably the better way of saying it. They're inverse operations, right? One thing undoes the other. All right, and then what's the next thing? Once we put the tire back on, do we let the jack down? No, we put the lug nuts on, right? So the opposite of loosen lug nuts is what? Tighten lug nuts, right? And in fact, to tighten lug nuts, do we turn them counterclockwise? No, we turn them clockwise, all right? So we do that. That's an inverse operation. And then the final thing we do is we don't jack the car up. The car's already jacked up. To get back on the road, we need to do the opposite of jacking the car up, which is letting the car down off the jack, right? So the car goes down. The car went up, and now the car goes back down. This may seem really simple, but this is the way we approach algebra. So when I look at a problem like this, I look and I say, I look at x. Here's x right here. What is being done to x on this side of the equals? Now the equals is a great big divide. It's a great big dividing line that's going to separate one side of this problem from the other. It's the key thing. All right, on this side, I have x, but I have a 14 added to it. I need to undo that. So I list out what's going on with x. X has added 14. There's a plus 14 over there. That's the only thing being done to x. So this is much simpler than the flat tire example. I just need to do the opposite of adding 14. So the opposite of adding 14, the inverse of adding 14 is subtracting 14. If I subtract 14 from over here on this side, then I'll have x all by itself. So let me write this out another way. So I have x plus 14, and I'm going to leave some space. I have my equals, and then negative 12. So algebra's main premise is whatever you do, you can do anything you want to both sides of the equals sign in any math problem, and it's totally legitimate. That's the beauty of algebra. Okay, so I have x plus 14. And over here I have negative 12. So I want to undo the addition of 14, so I need to subtract 14. So I'm going to come right here and just write minus 14. Right? I can't just throw that negative 14 in there or minus 14 without also doing it on the other side. So now I've just performed algebra. I just took something away from the left-hand side and took it away from the right-hand side as well. I did equal steps to both sides by just adding this minus 14. All right, so now look what that does on the left-hand side. I have x plus 14 minus 14. Well, what's 14 minus 14? 0. So now I'm left with x plus 0 on that side. And now on the right-hand side, I need to take these two numbers and add them. So remember, when you have two negative numbers, you add them and then make the answer negative. So I add 12 and 14, and I get 26. And so they're both negative, so that means it's negative 26. And now what's x plus 0? Well, when you add 0 to anything, it stays the same. So now we just have x then. We just get rid of the 0. and that equals negative 26, and that's the final answer. And so see, they also say up here, and this is a great idea, especially as you're first going through this, don't forget to perform a check. And when they say perform a check, that means come over here and see if that's true, this answer should work out. So in other words, put right here for x, put in negative 26. So let's come over here, I'll put it over here in this corner. So I had x plus 14 equals negative 12, and I know that x now is negative 26. And negative 26 plus 14 equals negative 12. And in fact, you can, at this point, if you want to, use your calculator. This is a great time. And as we start to move into algebra and we're comfortable with adding and subtracting negatives and all those operations, calculators are totally fine now. So I would pull out my calculator and try negative 26, which I'll do. I'll use the computer calculator here. So 26, I'm going to make it negative by pressing that button there. So I have negative 26 plus 14, and sure enough, I get negative 12. So that lets me know that I did this problem right. If I put the wrong answer in, this would not work out to be true up here. Right, so whenever I put in the answer that I get, if it makes a true statement, then I know I'm correct. And that's how you do one of these problems.